Now let's solve some problems using the nth term formula. This example says, is 300 or 400 a term in this sequence? And they've given us the nth term formula for a sequence. Now, a quick inspection of this to tell us what's going on. N has to be a whole number. Why? Well, because we've got terms in a sequence. We have the first term, the second term, the third term. We don't have the 1.5th term. So n's a whole number. Now, when you take a whole number, multiply it by 7 and add 20, you're still going to get a whole number. So what we're really wondering is, can you multiply something by 7 and add 20 and get 300 or 400 as your answer? Now, n will have to be a whole number. That's what we're looking for. So here's how I'd solve it. I'd say, let's let the nth term be 300 and see if it works out. So the nth term is all of this. It's 7n plus 20. Let's let that be 300 and see how we go. Solving this, we subtract 20 from both sides. And dividing both sides by 7, I can see that n would have to be 40. So in other words, if n is 40, then we're going to get 300. Now let's just double check. The 40th term, 40 times 7 is 280 plus 20, that makes 300. So yes, 300 is in the sequence. Now doing the same thing for 400, let's let the nth term be 400 and see if n is a whole number. So then 7n plus 20 would be 400, subtracting 20 from both sides, dividing both sides by 7, 380 divided by 7 is 54.28 something else, 5, etc., etc. So no, 400 is not in the sequence. So we would find that the 54th term of the sequence must be a little bit smaller than 400, and the 55th term must be a little bit bigger than 400. But none of the terms in the sequence are exactly 400 because this n didn't come out as a whole number. In this one, we need to see how many negative terms there are in this sequence. Now, rather than just blindly plugging ahead with some sort of method, always think about what this really means. As the n's are going up, first term, second term, third term, we're multiplying that number by 12. So this is similar to a line with a gradient of 12, isn't it? As each term goes up, we're going up by 12s. But where are we starting from? Well, we're starting from quite a negative number. Just think about it. The first term would be 12 minus 100. So that's minus 88. So if we're then going up by 12s, there's going to be a bunch of negative terms before then they cross the 0 and become positive. So how do we solve this? Well, we need to just let the nth term be less than 0 and then just see what we get for n and then think about it, make a careful conclusion. So if the nth term is less than 0, then 12n minus 100 must also be less than 0. Now let's solve this, add 100 to both sides. And now let's divide both sides by 12. Now, 100 divided by 12, that's 50 divided by 6, so that gives me 8 1/3. Now, it's not a whole number. Let's think about what it means. We know we've got a bunch of negative terms in the sequence that are getting bigger, and at some point it's going to cross the 0. Now, if n was less than 8 1/3, in other words, if n was only 8, it would still be a negative term. But if n is more than 8 1/3, then obviously it won't be negative anymore, it will be positive. So we want to know how many terms. We don't want to put an answer 8 1/3 terms because you don't have 8 1/3 terms. You either have 8 or you have 9. So n needs to be less than 8 1/3. We have 8 terms. How do I know it's 8 and not 9? Well, 8 is less than 8 1/3. 9 isn't. But also, always a good idea to check your answer. So 8 terms that are negative. Check what the 8th term would be. It's very quick and easy to do. 12 eighths is 96, and 96 minus 100 is minus 4. So yeah, the 8th term is negative. The 9th term, well, 9 12s, that's bigger than 100, so we're going to get a positive answer for that. So that just confirms that I've done the right thing. And this question's similar. It says find the first positive term if we have a sequence specified like this. Now this is similar to the last one. Obviously the terms are going up by 7. But we're starting on quite a small number, so there'll be some negative terms and then there'll be a positive one. We're not asked to find which term. We're asked what the term is. We want to find the first positive term. So we've got two jobs. We need to find its t-value, or what term it is, and then we need to find out what the actual term will be. So, same method as the last example, we want to let Tn be greater than 0, because we're looking for the first positive one. So we want it to be bigger than 0. So let's let 7n minus 60 be greater than 0, because that's what the nth term is. Let's add 60 to both sides. Whoops, 7n is greater than 60. So n is going to be greater than, what do we have here? 8 4/7. Now we need to think through our answer. What does this mean? Well, if we've got a bunch of negative terms, they're getting bigger and bigger until eventually they become positive. Then if n is bigger than 8 4/7, in other words, if it's 9, that will be the first positive term. And you can double check this. Check the 8th one. 7 8s are 56, minus 60. That's going to give you minus 4. So in other words, the 8th term is minus 4. But the 9th term, let's find out. We've got 7 9s are 63, minus 60, and that gives us 3. So to answer the question, just be really careful to go back and check what they've actually asked. They haven't said which term, in which case you might say the 9th term. They've said find the first positive term. Well, the first positive term is the 9th term, but that term is 3. So I would say, therefore, the first positive term is 3. And a careful conclusion like that just makes it really clear that you've understood the question and you've actually answered it.